Did you know mosquitoes are responsible for more human deaths than any other animal? From malaria to dengue, these tiny pests spread diseases that affect millions worldwide. But what if we could stop them before they even hatch? That's where AI is stepping in, and today we're diving into a groundbreaking project called VisText-Mosquito. So why is this important? Mosquitoes breed in stagnant water, and finding those hidden spots is like searching for a needle in a haystack. Traditional methods rely on people manually checking areas, which is time-consuming and often misses critical sites. But this new dataset is changing the game by combining images and text to train AI models that can spot breeding sites faster and smarter. Let's break it down. The VisText-Mosquito dataset has over 1,800 images of common mosquito traps. Think tires, bottles, and flower vases, each labeled with precise annotations. But it's not just about finding objects. The dataset also includes water surface segmentation, so AI can identify where the water is, and even natural language explanations. Imagine a model that doesn't just detect a tire full of rainwater, but explains why it's a problem. Discarded tires collect rainwater, creating stagnant pools perfect for mosquito larvae. The tech behind this. Researchers used state-of-the-art models like YALOV-9 for object detection, and YALOV-11-NSEG for segmentation. These models achieved near-perfect accuracy, over 92% precision in spotting breeding sites. For the text part, they fine-tuned a model called BLIP to generate human-like explanations, scoring high on readability and coherence. What makes this dataset unique? It's multimodal, mixing visuals and language, to create AI that's not just smart but explainable. This matters because public health workers need to trust and understand AI decisions. Plus, the dataset is open source, so anyone can use it to build better tools. This isn't just about mosquitoes. It's a blueprint for using AI to tackle global health challenges. By catching breeding sites early, we can prevent outbreaks and save lives. And with projects like VisText-Mosquito, the future of disease prevention is looking brighter, one AI-powered scan at a time. Ready to see how AI is turning the tide against mosquito-borne diseases? Stay tuned, and let's keep exploring the science that's shaping our world. Ever wonder how AI helps fight mosquitoes? Today, we're diving into a groundbreaking dataset that's revolutionizing mosquito surveillance. Let's break down how researchers are using AI to spot breeding sites, why it matters, and what the results mean for public health. Imagine a dataset filled with thousands of images from places where mosquitoes like to breed. Think puddles, tires, coconut shells. But this isn't just about pictures. Each image comes with detailed annotations, like labeling where stagnant water is or which objects could hold it. The text descriptions are super short, average around 230 characters, like stagnant water or potential breeding site. It's a goldmine of consistent, domain-specific language. Here's the cool part. The data is organized to make AI training a breeze. There are separate folders for training, validation, and testing. Each has images and matching labels. Think of them as the answer keys for the models. Plus, there's a special CSV file linking each image to a short reasoning text. This helps AI not just see, but understand why something is a breeding site. The team tested cutting-edge models. For object detection, they used YALOV-5s, YALOV-8N, and YALOV-9s. The YALOV-9s model. It crushed the competition with the highest accuracy, spotting containers like tires or vases that hold water. For segmentation, think pixel-perfect water surface detection. They tried YALOV-8XSEG and YALOV-11-NSEG. The YALOV-11-NSEG was a standout, catching more water patches without missing the mark. But here's the real twist. They trained a model called BLIP to generate human-like explanations. After learning from the dataset, BLIP could describe why an image shows a breeding risk. Metrics like BERT score and Rougeol showed its text was almost as good as human writing. Imagine an AI that doesn't just detect a puddle but explains, this stagnant water in a tire could breed mosquitoes. The results? State-of-the-art performance across the board. These models aren't just accurate, they're transparent, giving public health workers actionable insights. And the dataset? It's a blueprint for scalable mosquito control, combining visual detection with clear reasoning. So what's next? Expanding the dataset to more environments, refining the text annotations, and even using AI to suggest local interventions. This is just the beginning of how multimodal AI can tackle real-world problems. Thanks for watching. If you're curious about how AI is fighting diseases, hit subscribe. And drop a comment. What other real-world problems do you think AI could solve? Let's chat. Ever wonder how AI can look at a photo and understand what's in it? Or generate a description that actually matches the image? That's the magic of vision language models, systems that bridge the gap between visual and textual information. But training these models is tricky. They need to learn not just what an image shows, but how to talk about it in human language. Enter BLIP, a breakthrough from the 2022 International Conference on Machine Learning. BLIP tackles this by using a technique called bootstrapping, a clever way of letting the model teach itself. Here's how it works. Imagine you have a huge collection of images and captions. The model starts by learning basic connections, like a cat is often next to the word cat, but then it gets smarter. It uses its own predictions to refine its understanding, like a student grading their own homework and improving over time. The researchers tested BLIP on tasks like describing images, answering questions about photos, and even generating captions. The results? It outperformed previous models, especially in handling tricky details, like distinguishing between a dog chasing a ball and a ball being chased by a dog. The key was its unified approach. Instead of training separate systems for vision and language, BLIP learns them together, like a bilingual person who thinks in both languages simultaneously. So why does this matter? BLIP isn't just a technical win. It's a step toward AI that understands the world the way we do. Whether it's helping visually impaired users navigate photos or powering smarter virtual assistants, this kind of progress brings us closer to machines that truly see and speak. Next time you see an AI-generated image description, remember, it's the result of models like BLIP learning to bridge the gap between sight and words. Stay curious, because the future of AI is still being written.